Hello, and welcome to this e-learning security training video on authorization flaws. In the application that we are going to see, we have a crime investigation unit. So these are investigators that take information from witnesses to investigate cases. So the information is very sensitive. And they have some limited separation of duties in that limited investigators cannot even modify their own investigations. So let's have a look at this application. We have three users. Alice is the administrator, so she can see all the criminal investigation reports, while Eve and Bob are limited users, so they won't be able to view investigation reports for other users. So if I log in as Alice, this is what the homepage looks like. If I click on search, there are no reports found because there is nothing in the database yet, so we can create a new report. We can specify in there that this was reported by Joe Blogs, and this is the description of the crime, and we can specify in there the file to upload. So in here we have a couple of files, so sample evidence and sample evidence 2. So we upload one of those, and then when I hit submit, this crime report is added to the database and we can view it. And in here you can see that this crime report belongs to user Alice. Alice can edit this crime report, so she can change this. And you can see that the number 2 was added, so the update is working. And then the other thing that users can do is click on the view file to view the evidence file for the report. So if we click OK on that, we can see here the contents of this file. Another thing that Alice can do, and the other users as well, is to change the password. So in here we would enter the new password, and she can log out as well. Now if we log in as Eve and we click on search, there are no reports found because Eve can only see the crime reports for herself because she is a limited user. So if we create a new report, and attach an evidence file and hit submit, we can view the crime report, but Eve cannot edit the crime report. There's no edit link in here, but she can view the evidence file. Now if we click on search, we can see that Eve can see her own crime reports, but not those for other users. Now if we log in as Bob and we click on search, as it was the case with Eve, there are no reports found. We can create a new one and we attach a file, hit submit, click on view crime report. Again, no edit button here because Bob is a limited user. We can view the evidence file, and in the home page, if we click on search, now we can see the crime report for Bob. Limited users can change the password, and they can log out as admin users. And now if I log in as Alice again and click on search, we can see that because Alice is a system administrator, she can see all the crime reports for all users, and she can edit them as well. And this is the quick overview of what this application does. The first authorization problem that we are going to see is a case of privilege escalation through URL tampering. So what we are going to do is to log in as Bob. So now we are Alice. We log out, log in as Bob, who is a limited user. And then we click on search, and supposedly we can only see crime reports by Bob. However, if we pay attention to the URL, we can see in here that the user is set to Bob. So what if we change that to Alice? Then we can see the crime report by Alice. So this would be a vertical privilege escalation because we can see records that are meant to be only accessible to the administrator, who is Alice. And if we change this to if, this would be an example of horizontal privilege escalation because we can see the records by users that are at the same level as we are. So this is a very easy to exploit. No tools required. Just change the URL and you can exploit it. So this is a very simple example, but it still happens a lot in many websites. So how do we fix it? Well, to fix this, first we are going to create a fixed directory. So let's do that. So what this is doing is we are cding into the directory where we are working for this lab, then creating a directory of fixed. We are cding into that. We are copying all the PHP and TXT files into the fixed directory. Then we are copying the uploads as well. We are tightening permissions for the uploads, and then we are going to make the Apache user the owner of this uploads directory, because otherwise Apache will not be able to download the evidence files in there. So after that we are ready to implement the fix. So what we need to do is to go into home.php. So let's try that, and in here the problem is on this hidden field. Now this is a hidden field, but because the form is going to be submitted as get, we can change the hidden field from the URL. So it is really a case of changing the URL and not the hidden field. But the thing is that this hidden field here is really not necessary. So let's delete that. And what we want to do is in there. So instead of having this piece of code there adding the hidden field, which is going to be seen anyway in the URL as we just manipulated it, and what we need to do now is to add this check. So on the isSet request search, so this is this if in here, we need to add this security check. So if we do that, what this is going to do, if you pay attention here, this is building the query dynamically. So what this code is doing is, if the user is not administrator, then we are going to set the request user variable to what the user is. So this means that the user will no longer be able to pass itself as a parameter in the URL. It's always going to be forced by what this function returns. So if we save this, and I think that's everything, now we can verify what happens. So if we reload this, now we are logged in as Bob, so we should no longer be able to see records by Eve. So if we reload this, we can still see the record for Eve because we are not in the fixed directory. So let's change that. And now if we go into the fixed directory, you can see that the parameter for Eve is ignored, and we can only see records for Bob. So, and the same is going to happen if we try here user Alice. The URL tampering attack does no longer work. So we can only see records by Bob. The next problem that we are going to see is a privilege escalation through cookie tampering. So now we are logged in as Bob, and the URL attack does no longer work because we fixed it. So if we open Firebug, we will notice that there are two cookies. One says Bob and the other says 1. So UID seems like it's for the user ID, which is Bob, and GID seems for the group ID, which is 1. So if we edit this cookie and set it to Eve, and now we reload this page, we are able to see crime reports for Eve. So this would be the case of a horizontal privilege escalation attack where a limited user escalates privileges to those of another limited user. So now Bob can see records for Eve, which should not be possible in this application. And for the system, now Bob is essentially Eve. You can see it here on the homepage is welcoming Eve. So now Bob can see the crime reports for Eve and effectively be the same as Eve in the system. However, the problem does not stop there, because what if we change the group ID to 0 and the user ID to Alice? Then if we reload the home page, we have the user field, which we didn't have before. The system is welcoming us as Alice, and if we hit on search, we are able to see all the crime reports for all users. So we are essentially Alice, and we have escalated privileges from those of a limited user, Bob, to those of an administrator user, Alice. So this goes to show you that it's really a bad idea to put authorization inputs, expose them either in the URL, as we saw before, as well as in cookies, because they are really easy to change. So what we need to do now is to fix this problem. So let's see how to do this. The first thing that we need to do to fix this problem is to find all the files that are using cookies. So those in PHP will have the $_ cookie, or they will call the function setCookie. So these are the two principal manipulation ways of cookies in PHP. So if we save this from before, we clear that, and we run these commands, this tells us that there are 3 files affected: changepassword.php, init.php, and login.php. Let's start with login.php. In login.php, what this is doing is if the user is being logged in, right? So the user and the password is being checked in the query there. So if there's a match, this was previously setting this information, the user and the group, from the database in the cookies. And we saw just how easy it is to change those. So what we need to do is, instead of doing that with set cookie, we need to store that in the user session, which in this application, the session is already set up in index.php, I think. There you go. So session start is there in init.php, and this is why in this application all the URLs start with a question mark. So the request is going through index.php, which is then loading the file. Okay, so this is a different style of building applications. So there are different ways, so this is just one of them. Okay, so now that we understand that, we can change this to use the session. So we can add those lines in there, and the difference is going to be that the session is not going to be easy to manipulate for an attacker, while the cookies really are very easy to attack. So if we remove this, then by having this in the session, users will not be able to change these values. The only exception to this would be in a virtual hosting environment, where sometimes if permissions are not tight enough, sometimes an application can manipulate the session of another application within the same virtual host, in the same shared server, because the sessions are going to be saved in the same directory, and both applications will be saved, will run as PHP. However, generally speaking, if you only have one application, or at least applications you control on the server, the session is generally considered a safe place to store information so that users cannot manipulate it. Okay, so that is the first fix, login.php. The next file that we need to change is init.php, and in here there are these functions that are checking a few things. So this was already using the session for check if the user was logged in, so we need to change these two so that they are now querying the session instead of the cookie. So if we copy this, that is essentially what we need to do, change those from cookie to session. And now we should be good to go. So now everything in here is using the session, and now the last file that we need to change is changepassword.php, where we need to change this hidden field from using the cookie to using the session, because now remember there's not going to be a cookie with the username, so that needs to be changed. If we do that, this is the old line using the cookie, and this is the new line using the session. Okay, so at this point we have fixed all this cookie tampering issue, because now there's not going to be anything to tamper, right? So what we are going to do to verify this is to delete all the cookies. So now I'm going to delete this and delete this, and then we are going to log in as Bob and see what happens. Bob, and then in here you can see that we no longer have the cookies for the user and the group, so that problem, that fix in login.php seems to be working. And now in here, if we click on search, we can only see the data for Bob, and there are no cookies to change. So the cookie tampering issue has been solved. The other thing we can do is to go to change password to see if the user is being loaded correctly from the session, as we fixed in this line in here. So the user is shown as read-only from the session, so that is working and we have the right value in there. And now Bob cannot change the URL to change the user, and Bob cannot change the cookies either. So Bob is running out of options to escalate privileges. Now the next problem that we are going to see is a privilege escalation by manipulating hidden fields. So let's say we are logged in as Bob, and now we don't need this for now, and I click on change password. Okay, so this is the change password screen for Bob. So now if we use Firebug and we click on the inspect button and then go over here, we will notice that there is a hidden field with a value of Bob. So if we change this to Alice and we set the password to password, just going to type it again to make sure, and now I click on change password. Now I should be able to log in as Alice with a password of password, and you can see that I could. So there is a privilege escalation by manipulating that hidden field on the change password screen. So a normal user can change the password of the administrator to then be able to log in as the administrator. So that is that problem, and you could see how easy it is to change hidden fields using a tool such as Firebug. So how do we fix it? Let's see. So what we need to do is to avoid taking data from post. So we saw that the user can change the URL, that the user can change the cookies, but the user can also change anything on the post request, either with a tool like Zap or even with Firebug, as we saw it right there, just changing a hidden field. So what we need to do here is to change on the change password script. We need to change this query to take the username from the session, which the user cannot manipulate, instead of from post, which the user can manipulate. So let's try and do that. That was already changed password, so we only need to put that in there. That is the fix. So the fix is simply to change the query to take the username here from the session. So now we can delete this, we can save this file, and we are ready to go. So now, if, well, being Alice, we can change this to her previous password. And now if we log out, log in as Bob, and go to the change password screen, and then try to change the hidden field, which we still have in there, so that we can try this, and we change this to Alice, and we set a password of password again, and click on change password, go back to home, log out, try to log in as Alice with a password of password, and we are getting now invalid login. Please try again. So the fix is working, and we solved the problem of relying on hidden fields on the post request for authorization purposes. So now we are ready to remove this hidden field from the page. Now that we have verified that with Firebug, we no longer need this hidden field in here. So this hidden field is not necessary because this is going to be taken from the session anyway. So this is going to display the user, and this is going to update the user based on what is on the session. So if we log in now as Bob, and what is happening now is that I changed the password of Bob to password instead of the password of Alice. So now we have to log in with Bob and a password. So now I can go in here and I can reset the password of Bob back. So now the user does not even have this hidden field in here, which it would be ignored anyway. So now there's just the text of the value of the username in the session. So if you notice in this video lab, this is all removing exposure from the client side. We are removing hidden fields, we are removing cookies, and we are removing parameters from the URLs, and we are moving everything into server-side control. So you are going to find this theme to repeat itself during the course a lot, because that is the best way to defend our application, to simply remove all the possible entry points from the client side and have server-side controls. So that solved the problem of hidden field privilege escalation through hidden field manipulation. The next problem that we are going to see is an authorization bypass because of files being accessible on the web root. So let's see what this means with an example. So now we are logged in as Alice. We can log out. And what if someone goes directly to this URL? They can see all the uploads that have been done through the application. So they can see all the evidence for all crime reports. So this is an authorization bypass because any user, even without a login to the application, can see all this sample evidence. So how do we fix it? Let's prepare a directory outside of the web root for this. So what we need to do to fix this problem is to move all these uploads away from the web root. Then they won't be able to be accessed directly. So let's do all this. And if we do that, what this is doing is it is preparing a directory on home www authorization lab1 uploads, and this is going to be the new uploads directory. Then the uploads directory here is being moved to that directory, and then it is setting the permissions so that only the owner can write, read, and execute from this directory, this uploads directory. And then finally we are making the Apache user the owner of this directory, because the Apache user needs to be able to write in here so that the application keeps working as intended. So after doing all that, we are ready to change the application to use this new directory outside of the web root instead of the web root. So The first thing is to set up a global constant. So we can do this with a define like this, and here we are defining a global constant called upload_dir, where this is going to be set to this directory in home where the uploads are going to be. So if we save this, the next file that we need to change is viewfile.php, and in here we need to first add this line, because without this the new constant will not be seen, because the constant is declared in this file, right? And then we can add this line. So this was the old line with a hard-coded path, and now we are using the path for the upload directory indicated and defined only once in this central file. So now we can delete that, and if we go to edit report.php, we can search for uploads, and in there we just need to use the new constant as well. So we can do that. And the other file that we need to change is new report.php. Search for uploads, and in there we use the new constant. So let's do that. And after doing all this, the end result is that if we go to uploads, we are getting a not found, so this attack is no longer possible. But if we log into the application, we should still be able to see the evidence files. So if I click here on view evidence file, we can see that we can read the file correctly. And if we log in as Alice, for example, and we go and view an evidence file for Alice, we can read it as well. So not only does the fix work, but the application remains working. So this is all very important. Very important when you implement a security fix is to make sure that the functionality of the web application remains working as normal. So we fixed the authorization bypass because of direct access to files in the web root. The next problem that we are going to see is an authorization bypass because of direct access to PHP files. So if we go to the browser, we go to the home page, now we are logged in as Alice. Let's open Firebug and go to the cookies and delete this. So now we have no cookies, so we are not logged in. If we refresh this page, because this is going through the front controller, it should kick us out to the login page. So if I reload on this, we go back to the login page, and a new session ID is given to us. Okay, this is because in index.php there is a check that if the user is not logged in, they are going to be redirected to the login page. When we deleted the session cookie for the application, we were no longer being logged in. So this is why when we refresh the home page, the front controller loaded the login page, as you saw here. However, it is still possible to attack the files in the web application individually. So at this point, without a login and deleting this, if I go directly to home.php, you can see that I'm not logged in at the moment, but effectively I am an administrator without any cookies, without any session, so we can pretty much escalate privileges to administrator without even having a login by attacking the PHP files on the web root individually, because this is a user without a login, without a session, and we are able to see the crime reports for Alice, Eve, and Bob. And the same happens if we go individually to other files, such as viewReport.php. We can see this crime report for Eve without being logged in. So this is a special case of a direct object reference where the user is not logged in, but PHP files can be referenced directly by passing the check in the front controller, because the other files are exposed in the web root. So we can do that, choose edit report, and we can of course view the evidence files as well, even though those are outside of the web root. We should be able to see them. There you go. So that is the file, and this goes to show you that having a lot of files on the web root it increases the attack surface of the application, because each of those PHP files can be attacked individually, and the same concept applies to any platform, not just PHP. And then the more files you have on the web root, the more files that can be attacked individually, and the more potential for security problems. Okay, so now that we saw what the problem is, let's try to fix it. So the solution here, of course, is to move even more files away from the web root. So let's prepare the directories for that. So what this is doing now is creating a directory for the source code of the application. Then we are moving all the PHP files away from the fixed directory and into this source directory on home www. And then we need to have index.php back in here. So now we have significantly reduced the attack surface of the application by just having one file, one PHP file directly accessible through the URL. So we only have one file on the web root and everything else is outside. So this is going to make the application much more difficult to attack, and attacking individual PHP files is no longer going to be an option. Now everything has to go through index.php, which makes defense a lot easier because we can centralize security controls here instead of having to defend a lot of PHP files one by one. Okay, so now that we have done that, we need to change the appdir directory to the new one. So let's do that. This is index.php, and you can see here there is this constant being defined. So what we need to do is to change this to have the new directory. So instead of doing all that, we are going to do this, because remember now init.php is no longer here. Here we only have index.php. Init.php is on home as well. So we need to first define the directory and then we can load init.php. So we don't need this, which was the old way of doing things. And the other things that we need to change in here is view report.php. So we need, on this file, what we need to do is to change the link to view file, which before was not going through the front controller. It was a direct access. So now this needs to be changed like this. Let me show you the difference. So this was before, where viewfile.php was being accessed directly, and this is after, where viewfile.php is going to be accessed through the front controller, which is enforcing authentication. Okay, so now we can delete this. This is the fix for that. And that is all that we need to do. So we can now close this, and we can try and see if the fix is good. So if we try to access these files individually, because the files are no longer on the web root, so for example, if we try to access this, it's going to fail, the same as this, and the same as this, and the same as this. So all these attacks that were targeting individual PHP files are no longer possible. Now everything has to go through the front controller that we have in index.php, and that is the only way to access the functionality on the other files. So we solved the problem of direct attacks against PHP files, which allowed authorization bypasses by seeing crime reports for other users without even having a login. The next problem that we are going to see are path traversals. We have two different path traversals which follow two common patterns. A front controller trying to load files and a script trying to serve files from the file system. So these are two very common scenarios for path traversals. And what we can do is to first look at the code in index.php, and you can see here that if the user is logged in, then whatever is passed in request F, so that is what F has, is going to be loaded and executed as PHP code. So this would be the case of local file inclusion, but for our purposes, the difference between local file inclusion and traversal is not very big, because usually the local file inclusion, if it is not PHP code, is going to give us the file anyway. And the only difference is the local file inclusion is going to execute the file if it contains PHP code. But for our purposes, we're going to treat both of these as traversals. And this is a path traversal or a local file inclusion, but not a remote file inclusion, because at the beginning of the statement there is going to be this constant. So the attacker can only manipulate what goes after this and does not control the start of the string. So they cannot pass an F like HTTP something else to load code on their web server, for example. That attack is not possible because at the beginning there is going to be this directory. This is why this is not a remote file inclusion, this is a local file inclusion. So that is index.php. And now what we can do is have a look at the other traversal vulnerability on viewfile.php. So this one is trying to load the file from the upload directory. So whatever is passed on get file is going to go in there. Now, because view file has been moved to the home directory, now the path traversal is going to require authentication, because in index.php, if the user is not logged in, they are going to be kicked out to the login page. So this is why front controllers are a very good idea. They keep security very simple. Okay, so now that we have seen the vulnerabilities in the code, let's try and see how what exploitation looks like. So if we need to be logged in for this one, so let's log in as Bob. And now let's try that attack. So this is what the attack looks like, and what we are doing is on F, we are adding a sequence of ... until we walk out of this directory. So there's going to be ... to get out of here, 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 and then we move up to etc password. So this should show us the etc password file. And you can see there. Now, on the browser it doesn't look great, but what we can do is to copy this, go to the terminal, and try this with curl. Of course, we need the session cookie, because this attack, now that we can no longer attack the PHP files individually, now this requires authentication. Let's try and copy that correctly. So copy, and now we need to pass the session cookie. Hopefully I'll get it right now. Copy, and I'm going to paste it like this. Okay, now we got it, and in here we just delete this. So what this is doing is curl is going to access this URL, but it's going to use this cookie, which is the session cookie of Bob, which we can simply copy from Firebug like that. So now if we hit enter on this, we can see the etc password file. And like this, we could get all the files from the file system. So this is what a traversal attack generally looks like, this ... sequence. Okay, so that is the first traversal, which is on index.php on the parameter f, that's trying to load a file, PHP file to execute from the web application. And then there's a completely different path traversal on the view file and file parameter. So if we try that from the browser, now that we are logged in, this is what the vulnerability looks like. Now the parameter f is calling viewFile.php, and the traversal is on the file parameter that is going to be used by this file. So if we hit enter on this, we should see the etc password file as well, but because this serves the file as an attachment, we are getting it like this. So it's a little bit easier to read like that. Now we can of course do this with curl as well. So we can load this from before, and in here we can simply put the URL, not this URL, but the new one. I can copy it from there, and then we need single quotes, and we can paste it. So now I have to add this HTTP in here, and we are ready to go. So this is the session ID for Bob, and then this is the new URL. You can see f is viewFile.php. There's no attack in f now, as there was before. The traversal was on f before. Now the traversal is on file, on the parameter file, and you can see there. So now if I hit enter, we can see the contents of the etc password file, but this is a different vulnerability on another file and another parameter. Okay, So we saw the traversals. You can play with those and try to retrieve other files from the file system. But that is essentially what that traversal looks like, and we're going to have a look at how to fix this problem, because this is an interesting example, because the functionality for index.php and viewfile.php is different, so the fixes are going to be different as well. The idea of index.php, if we look at it again, is to load a PHP file from the web application and run it. That is what index.php is meant to do. So the fix for index.php is really to build a map of the allowed files, which we can do in a shell one-liner like that, and that is going to give us an array of the allowed files. So what I have done right there is simply cd into the source directory that we created before, and then we are doing an ls of all PHP files. We are translating the new lines into blank spaces, and then we are using the set command to replace white space by quote, comma, quote. Then we are replacing the start of the line with array and opening parentheses and a single quote, and then we are replacing the end of the line, which has a comma and a quote, and we are replacing that with a closing parenthesis and a semicolon. So this returns a convenient array for us, very simply, just with this line, of all the possible files that this application has. Okay, so this is a quick trick for you. Of course, you could do the ls recursive if you had like subdirectories. Okay, so that returns an array like that, and now that we have the array, we can go back to the fixed directory, and on index.php, this is what the code was doing before, and this is what we need to do. So let's paste that in there and compare. So this is the fix, and this is the old code. So f request f, so that is the same thing. Okay, we can delete that. Then this was just checking if the user is not logged in and the file is logged into PHP, or there's no file, then go to logging. Now we are adding a check, and or not in array, we're defining here an array of allowed pages. These are the only pages that can be loaded in this application, which are the only legitimate PHP files that this website should load. So what this fix is doing is it is checking that if the file supplied is not in the list of allowed files, then we're just going to show the login page, because that file is not allowed. So this fix is very simple in a front controller, as you can see, but very, very effective, because by having a list of the only values that you allow, this is the strongest validation possible, and this removes all surprise elements and all tricks. You are comparing against a list of known good values and rejecting absolutely everything else. Everything else is going to have the login page. So the fix for index.php is relatively simple. Now we need to keep this else, because if all those checks are not the case, then we are going to run the file, because this file is going to be one of these files in here. So now we are ready to save this file, and after doing this, we can verify if the fix on index.php is working or not. So if we try to attack this parameter, this is going to through index.php because of the question mark. So we are trying to exploit the same path traversal as before. We are getting the login page because that is not in the whitelist of only allowed pages for this web application. So you can see this security control is very effective, while at the same time is very simple. So if we try the attack using curl, which we have with the correct session from before, you can see the attack in here. This is the F parameter. We are going to get the same thing. We get the login page. We are no longer getting etc password. So we fixed the first path traversal. So the best fix for a path traversal in a front controller is to have a map of allowed files and reject everything else. Okay, and that is the simplest fix. Now, on the other path traversal, we need a different approach, because in this case, we do not know the files that are going to be there. We could build a map each time, but that would be a little bit messy to read from the directory each time. So what we are going to do instead is to use a different defense technique for this. And if we edit this file, what we need to do, this is what the old code looked like, and this is the fix. So let's copy this. We are adding a few debugging statements so that you can see what the fix is doing. So we are adding all these checks before the file is finally read. What this is doing is, first, we are calling real path. Very highly recommended in PHP to always call this function to avoid path traversal attacks. We're calling real path with the full path. So this is the file that is supplied by the user. This is the directory where we intended to upload the file. And then after calling real path, then we are calling base name, which is going to give us the file name. So in here we have added an echo now to test the fix to show what file this file variable is going to contain. Then, after all this sanitization here, we are adding the upload directory to the beginning of the file name. Okay, this is after all this in here. And then we are showing what this file path looks like. Then if that file is not readable for PHP, then we are going to say it is not found, and we are going to show this. This is only for debugging reasons now. And then after all those checks, if everything is fine and the file is readable, then the file will be shown to the user. Okay, so we can now save this. And now, if we try the attack on viewfile.php with curl, we should verify that this issue has been fixed. So this is the curl command from before with the session from Bob. This is viewfile.php, file parameter with a traversal attack in there. Now if I hit enter on this, we are getting that the file is the password file. And you can see that all these ... are gone. The real path followed all this and cleaned all that attack. So by calling real path and then base name, we get the name of the file without any tricks. And then we are adding the uploads directory in front of the file that is passed by the user. Then, because this file does not exist in the uploads directory, this is showing that the file is not found. So this was our third debugging echo in here. This is this dying here. So you can see that the fix is working fine. So we can explain it a little bit step by step so that you can get the drift. This is what is happening. Okay, we can emulate it. So there is an uploads directory, and we are appending to that what the user passed, which is the traversal attack. Okay, and this is going through real path. So real path is going to evaluate this path and give us what the real path is going to be after following all these dot slashes. So if we hit enter on this, we get that the real path of all this is etc password. Now the next step that we are doing is to call base name after that. So we are doing base name from the output of real path. So this returns the name of the file without any dot slash tricks. Okay, and this explains why this first echo in our script returned that value. Now, the final thing that we need to do is to emulate how we are adding the uploads directory finally at the beginning. Okay, so that is what we are doing. So this is the traversal attack, and we are adding the uploads directory. In front of that we are doing the real path of that, then the base name, and then we are adding the uploads directory in front of all that. So that gives us the upload directory like that. So this is a very good mitigation technique against path traversals in PHP. You should check a platform function similar to real path depending on the platform that you are using. But the idea is you need a function that is going to resolve the path passed by a user to what the real path is going to be finally on the file system. Okay, so now that we know how the fix works, we can go back to viewfile.php and remove all those debug statements now that that is clear. So this is what we want to do. So we can now delete this. So you can see on the file not found, then this was the file path. Now we are removing that in here, so we are not going to provide that information to the user, and that is this fix. So now we fixed the traversal problem on both files, on index.php, where we could use a whitelist of allowed values because we know which are the PHP files to load in this web application. And in the case of viewfile.php, we cannot use that technique because the number of files is going to change as users keep uploading evidence, and building that map dynamically would be messy. So it is quicker to simply use this technique to first resolve the path, then get the file name of that, and finally prepend the upload directory and check if you can read the file before trying to read it. So this fix is an effective fix against path traversals in cases where you cannot have a whitelist of allowed values. So we saw these two fixes for path traversals depending on what the functionality is. The final problem that we are going to see is the issue of direct object references. So I really like this type of problem because as you will see, it doesn't follow any special pattern and the traffic looks normal at all times. So I have just logged in as Bob, okay, and then I hit search, so I can only view the crime reports for Bob. Until there everything is fine. I hit on view, and then on here a direct object reference attack is going to change. Well, one way is very typical, is to change the ID in the URL. So the ID is supposed to be a number. Like, remember that path traversal that we just saw has a very specific signature. There's going to be something like a dot slash or an equivalent, depending on the operating system. Might be a backslash, but the thing is, there's a clear attack pattern. But in this case, if I change this ID3 to ID1, this has just showed me the
the crime report for Alice being Bob in the web application. Okay, so this is a serious problem because I'm able to view sensitive information that should not be accessible to Bob, to this user that I'm logged in as. But what I want you to pay attention to is the fact that there is no clear attack pattern for this one, because the ID is a number and it's a valid number. So the problem really is that in the code there needs to be a check to make sure that this user that is logged in and is sending a valid ID, which returns a record, is really able to view that record according to the business rules of the system. So to defend against direct object reference attack, the development team needs to add checks in the code, and because this requires the developer to remember to do something, it is very easy, because it's human nature to forget things, to forget some check here or there in a big web application. So if you just forget one if on the right place, then it's going to be likely that it's going to be a direct object reference. So while the problem is very simple to exploit, it's relatively difficult to fix, in that you need to go through the whole web application. Imagine like if it's a huge web application, like 10,000 files, and make sure that all the ifs are on the right place. So this is why I'm going to show you some techniques to centralize this checks so that defense is a little bit easier. Okay, so we could see that with this attack I can view the crime report for Alice, the crime report for Eve, and of course the crime report for Bob, which is the user I'm logged in as. So this is a big problem, and let's see how to fix it. An even bigger problem is that you can even change crime report. So if you change view to edit, you could even change a crime report for the administrator user. So this is even a bigger problem than just accessing information that you are not meant to access, but you're also accessing a PHP file that you should not be able to access. And this is often the case where, because of having a nice user interface that is friendly and does not show the options that are not allowed to the user, then it's easy to forget to add a check on the server side to make sure that these things that have been hidden from the user interface, such as edit crime report, which is a button that Bob doesn't have, it's important to remember to add those checks on the server side, even if there are some the links have been removed from the client side on the web application. Okay, so now let's try to fix this one. And to do that, the first file that we are going to fix is viewReport.php, and in here viewReport.php is a file that can be accessed both by limited users and by administrator users. The difference is going to be that administrator users are going to be able to edit. They are going to have this button to edit, right? But essentially both users are allowed to view this page. This means that the front controller is not the right place to add this check, but we have to add this check on this file, because this file can be accessed by several user roles in this application. So this is what the vulnerable code looks like, and this is what we need to do. Okay, so essentially the beginning is the same thing. We are initializing the query to what it was. Okay, so we can delete that line. And the new thing that we are doing is we are checking if the user group is not 0, so this user is not an administrator, then we have to modify the query so that it only shows records that belong to the user ID in the session. Okay, so that is the fix for this one. And now, after I have saved this file, if we go back to the URL and we try to view report, which is the file we have fixed, of ID1, which belongs to Alice, we should get an error. Okay, crime report not found. However, if we try to being logged in as Bob, view our own record, then we are able to view it. So this fix is working as intended. We should also not be able to see the crime report for Eve, which was ID2. Okay, so we're getting this error as expected. Crime report not found, because we're changing the query to include the user in the session variable. Okay, so we cannot view reports for admin, we cannot view reports for Eve, we can only view our own. So the first problem has been fixed. We still have the problem on editReport.php, which we didn't change. But this check, instead of modifying editReport.php, is best placed on the front controller, okay, because this is different. So the case of viewReport.php is a file that can be legitimately accessed by both roles, limited users and administrator users. Now, edit is a function that in this web application is only available to the admin user. So because of that, we can add another array here of admin pages where we are going to add this editReport.php. So the other files, change password, view file, view report, all these other files can be accessed by a limited user. But editReport.php is a file that in this web application a limited user should not be able to access. Okay, so we are defining this new array of admin pages. Okay, and this is an array defining pages that should only be able to be accessed by admin users. And so once we have this defined, we can add this check to verify that let me see if I add this here, to verify that not only is the file in the whitelist, but we are adding this check here. Okay, I'm just checking if we have the parentheses right. We do. Alright, so what is this doing? We have this check. If the user is not logged in, show the login page. If the file is login.php, show the login page. If there's no file supplied, show the login page. If the file is not in our whitelist of allowed files, show the login page. Or if the user group is not administrator, so it's different than 0, and the file is in the list of administrator pages, then in this case we are going to show the login page as well. This means that the front controller makes these types of checks simpler. So imagine like you have 20 pages are only for the administrator while 300 pages are allowed for everybody. So this type of configuration makes that easy to configure and centralize in a single place. Okay, so now after this fix we have saved the file. So in here, if I reload this page being logged in as Bob, I should be kicked out to the login page. So if I do that, I am kicked out to the login page, so this is working as expected. However, if I log in as Alice, I should be able to edit any crime report, and that is working correctly because the group in that case is going to be 0, so this check does not apply to Alice, who is our system administrator. So we fixed the problem on edit report.php and we verified it. And now the final file that we need to fix is viewfile.php, and this fix is a little bit more complicated because what happens is that this script is serving files from the file system. Okay, so what this gets is the file name, but we need to get from the file name if the user that is sending this request is really allowed or not to read this file, right? So this is a very strong reason for you to avoid storing files on the file system, because then it is more complicated to enforce permissions by users. Like, for example, on viewReport.php, we could simply add an AND to the query. If the record does not belong to this user, we are not going to show it. But here we cannot do that because the file is on the file system and all this script is getting is getFile. Now, thankfully, the web application starts the file name with the ID of the record, so we can get that from the file name and then try to retrieve that crime report for that user and verify that. So let me put that in there and I will explain it a bit better. So these are the checks that we had before to avoid the path traversal, and that remains the same now. The new checks are this. And what this is doing is, after we do the whole path traversal mitigation here and we get the file name, which is in $file, we need to explode that. And let me show you another file and you will see what I mean. So if I go to, let's see, view or edits report.php, okay, in here viewfile.php is loading, is being built, the file name is being built with the ID from this record and then the evidence file name provided by the user. So we have these two rows. So this allows us from the file name to get the ID and then look that up in the database and check if the user is really allowed to view that record or not. Okay, so now we can go back to viewfile.php, and because we have the potential path traversal attack, we are adding this additional checking here. So we are going to get the first part of, so the file is supposed to have an underscore, so this explode is going to return an array of the file name where each element is something that is not an underscore, and we are getting with array shift the left of that, so the first thing before an underscore. And if there are no underscores, this is going to give us the file. So the same thing as here is going to be an ID. This is why in here we have a check that if this ID is not a digit, then we're going to say invalid file. That's it. Now after that, and remember, administrator users can view everything, so this check has to be done only when the user is a limited user, only when the group is different than 0. Then we can build a SQL query to search crime reports where the ID is the one supplied by the user, which we have already validated to be a digit, and the user is the user ID in the session. Then we are running that query. And finally, if we get no rows, that means that either the ID is not valid or that that user cannot read that file. So then we are going to stop that before we read the file from the file system. So this checking here is all that's necessary in this web application to mitigate a direct object reference to retrieve files from the file system that the user should not be able to access. Okay, so this should stop Bob from retrieving these files. Let's try and verify this fix. So now I'm logged in as Alice. Okay, so if I search and I view this for Alice, I can click on view file, which is that one. I'm going to click with the middle button on the mouse, and that will keep this URL handy for us here. So if we hit enter on this while being logged in as Alice, we get the file. Now if on this tab I log out and log in as Bob, and then I reload this tab, I should not get this file. I should get the error that we just implemented. So if I hit on OK, we are getting a file not found. So our fix is working correctly. Now if we log out and we log in as Alice and then try to view the file, in this case the file should be displayed correctly because Alice is allowed to view this file. So if I hit OK, we get the contents of the file. So we have mitigated the direct object reference vulnerabilities while at the same time the application remains working as intended. And this concludes this lesson on authorization flaws. Thank you for joining us.